Now we are seeing the integral equation which are going to solve using the Fredholm alternate theorem, right? So next problem, solve the integral equation g of s is equal to f of s plus lambda into integral 0 to 1 minus 3 st g of t dt. So we'll see the solution first. Given equation, right, g of s is equal to f of s plus lambda into integral 0 to 1 minus 3 st g of t dt. That is equation number 1. Here the kernel k of s comma t is equal to 1 minus 3 st. It can be written as a1s into b1t plus a2s b2t. Here a1s which is equal to b1s which is equal to 1, both are 1, so first term 1, right? Then the second term can be splitted into 2, that is a2s is minus 3s and b2t is t, right? So this is separable kernel. We know that aik which is equal to integral bi of t ak of t dt. Put I is equal to 1, so a1k which is equal to integral 0 to 1 b1 of t ak of t. When k is equal to 1, a11 which is equal to integral 0 to 1 b1 of t a1 of t dt. That is equal to, substituting the value of a1 b1, so you will get 1 into 1, so dt. So integral dt is equal to t, upper limit 1, lower limit 0, so you will get 1. Therefore a11 equal to 1. That is equation number 2. When k is equal to 2, a12 is equal to integral 0 to 1 b1 of t a2 of t dt. Substituting the value of b1 of t and a2 of t, 1 into minus 3t, so minus 3t into dt. So integral minus 3t is equal to minus 3t square by 2, lower limit 0, upper limit 1, right? So substituting the upper limit, so minus 3 by 2. This is a12 is equal to minus 3 by 2, that is equation number 3. Next, put I is equal to 2, right? So I is equal to 2 means a2k which is equal to integral 0 to 1 b2 of t ak of t dt, right? So when k is equal to 1, a21 equal to integral 0 to 1 b2 of t a1 of t dt, which is equal to integral 0 to 1, substituting the values, so b2 of t and a1 of t, you will get t dt. So integral t dt is equal to t square by 2, so 1 by 2. So this is equation number 4. Next, when k is equal to 2, a22 is equal to integral 0 to 1 b2 of t a2 of t dt. Substituting the value of b2 of t and a2 of t, you will get minus 3t square dt. So integral minus 3t square dt is minus 3t cube by 3, so that is equal to minus 1 by 3. Upper limit minus t cube, right? Upper limit 1, lower limit 0, so you will get minus 1. So a22 is equal to minus 1. This is 5. So to find the eigenvalue lambda, we know d lambda is equal to 1 minus determinant value. So 1 minus lambda a11 minus lambda a12 minus lambda a21 1 minus lambda a22. Substituting the value of a11, a12, a21 and a22. So we will get 1 minus lambda, right? Then minus 3 by 2 lambda, minus lambda 1 by 2, 1 plus lambda. This is in the second row of the determinant. So solving the determinant, 1 minus lambda into 1 plus lambda, so cross multiplying, so minus into minus plus, right? Lambda square 3 by 4. So that is 1 minus lambda square plus 3 lambda square by 4. So taking LCM, 4 minus lambda square by 4. If d of lambda equal to 0, solving the determinant, right, the equation, right? So 4 minus lambda square by 4 equal to 0. So 4 minus lambda square equal to 0, lambda square equal to 4, lambda is equal to plus or minus 2. So there are two eigenvalues, lambda 1 equal to plus 2, lambda 2 is equal to minus 2. Next, we know that Ci which is equal to integral 0 to 1 bi of t g of t dt. When I is equal to 1, C1 equal to integral 0 to 1 b1 of t dt. Substituting the value of b1, so b1 is 1, right? That is equal to integral 0 to 1 g of t dt. that is equation number 6. When I is equal to 2, C2 is equal to integral 0 to 1 B2 of t g of t dt, that is equal to integral 0 to 1 B2 of t is t, so t g of t dt, that is equation number 7. So 1 implies g of s is equal to f of s plus lambda into integral 0 to 1 minus 3 st g of t dt, so that is equal to f of s plus lambda into splitting the integral into 2, 1 into g of t dt, that is integral 0 to 1 g of t dt minus 3 st g of t dt, so minus 3 s lambda into integral 0 to 1 t g of t dt. So that is g of s, which is equal to f of s plus lambda into, from 6 and 7 we are substituting the values, lambda c1 minus 3s lambda c2, right? Hence the general solution is g of s is equal to f of s plus lambda c1 minus 3s lambda c2 if lambda not equal to plus or minus 2. We know that for homogeneous equation, the system of linear equations are given by Ci minus lambda sigma k is equal to 1 to 2 aik ck, which is equal to 0. When I is equal to 1, C1 equal to lambda minus lambda sigma k is equal to 1 to 2 a1 k c of k equal to 0, C1 minus lambda doing expanding the summation, right? So a11 c1 plus a12 c2, which is equal to 0. So this implies C1 minus lambda into substituting the value of a11 and a12, so minus lambda into C1 minus 3 by 2 C2 equal to 0, right, by using 2 and 3. So that is equal to, so 1 minus lambda, grouping this C1 term, right, 1 minus lambda into C1, then plus 3 lambda C2 by 2 equal to 0. If lambda equal to 2, 1 minus 2 C1 equal plus 6 C2 by 2, substituting the value of lambda equal to 2 in the above equation, right? So minus C1 plus 3 C2 equal to 0, C1 equal to 3 C2, that is equation number 8. When lambda is equal to minus 2, 1 plus 2 into C1 minus 6 C2 by 2 equal to 0. So you will get another equation, 3 C1 minus 3 C2 equal to 0, C1 equal to C2, that is equation number 9. Considering the homogeneous equation of 1, g of s is equal to lambda into integral 0 to 1 minus 3 st g of t dt. So this implies lambda s is equal to lambda c1 minus lambda s 3 c2, right, minus 3s lambda c2, that is equation 10. To find the eigenfunction, if lambda is equal to 2, 10 implies g of s is equal to 2 c2 minus 6s c2. G of s is equal to 2 into 3 c2 minus 6 s c2, right, because c1 equal to 3 c2, substituting the value, right, by using 8. So g of s is equal to 6 c2 into 1 minus s. G of s is equal to c into 1 minus s, where c is the constant 6 c2, right? Therefore g of s is equal to c into 1 minus s, that is equation number 11, which is the eigenfunction corresponding to the eigenvalue lambda is equal to 2. If lambda is equal to minus 2, 10 implies g of s is equal to minus 2 c1 plus 6 s c2. So g of s is equal to minus 2 c2 plus 6 s c2, because c1 equal to c2 using 9. So g of s is equal to 2 c2 into 3s minus 1. G of s is equal to 3 c into 3s minus 1, where c is equal to 2 c2. So therefore g of s is equal to c into 3s minus 1. So this is the eigenfunction corresponding to the eigenvalue lambda is equal to minus 2, right? We know that by Fedlam alternate theorem, here the transpose equation corresponding to the homogeneous equation g of s is equal to lambda into integral 0 to 1 minus 3 st g of t dt, given by first, when lambda is equal to 2, the transpose equation psi of s, which is equal to 2 into integral 0 to 1 minus 3 st psi of t dt, right? That transpose equation is, we know psi of s is equal to lambda into integral 0 to 1 from the theorem, right? 1 minus 3 st g of t dt, right? Instead of g of s we are putting psi of s there, right? So when lambda is equal to 2, substitute lambda is equal to 2 there, right? Where psi of s is equal to c into 1 minus s, right? The first case, 11, equation number 11, right? When lambda is equal to minus 2, the transposed equation psi of s is equal to minus 2 integral 0 to 1 minus 3 st psi of t dt. So you have to use the equation 12 where psi of s is equal to c into 3s minus 1, right? By alternate theorem, solution psi of s if and exists only if and only if the inner product f of s comma psi of s is equal to 0. Hence, if lambda is equal to 2, the integral equation 1 has the solution if f of s satisfy the equation inner product of f of s comma psi of s equal to 0, that is substituting the value inner product of f of s comma c 1 minus s, c into 1 minus, because psi of s when lambda is equal to 2, psi of s is c into 1 minus s, right? Equal to 0, that is equal to, using the inner product space definition, integral 0 to 1 c into 1 minus s f of s ds equal to 0, that is integral 0 to 1 minus s f of s ds equal to 0, because c is the constant and on the right hand side you are having 0, you can cancel c, right? Hence, if lambda is equal to minus 2, the integral equation 1 has the solution if f of s satisfy the equation inner product of f of s comma psi of s is equal to 0. Place a inner product of f of s comma c into 3s minus 1, that is 12th equation, right? Which we have used, right? Instead of g of s you put psi of s, right? So you will get c into 3s minus 1, which is equal to 0. So that is integral 0 to 1 c into 3s minus 1 f of s ds equal to 0. That is integral 0 to 1 3s minus 1 f of s ds equal to 0, right? That is the solution. Thanks.